Good morning, everybody. This is the student Moaaz Mohammed, and today we're going to be doing the operation on the Hoffman voltmeter experiment on the VLAB website. So, in this experiment, the components you're going to need is this Hoffman voltmeter, some water, some some sulfuric acid, an ignited splint, a battery, and two connectors. So, you're going to need to first connect these two right here, and then add some water to the Hoffman voltmeter. Before we add the acid, I want to tell you what this experiment does. This locates the water's covalent bond and separates hydrogen at the negative cathode and oxygen at the positive anode. So let's acidify the water so it could be electrically conductive. We pull up to take some acid, and we pull down to release the acid in the water, making a diluted sulfuric acid solution. So as we can see here, some gas is forming, and as you can see that it's double the amount. So this here is oxygen, which helps in burning. So when we open the gas valve and we place the match near it, the match flame is going to be much larger. But if we place it near here, which is hydrogen, it's going to burn with a pop sound. So let's get right to it. Alright, let's open the valve. Let's see what happens when we put it near the. See, it burns with a pop sound. But then when you place it near the oxygen after I open the valve, the flame is going to be larger, as oxygen is a gas that helps in burning. So how does this device work? So this device works using electricity, and electricity is apart from ultraviolet, is one of the only ways to separate atoms in a chemical bond. So, and you might wonder, why do we acidify the water using sulfuric acid? Sulfuric acid is an example, but it's the one we're given here. So we acidify the water to make it electrically conductive, as pure water in and itself is not a good conductor. So let's grab the match one more time and confirm this is the cathode, the negative cathode, which hydrogen forms at, and it's double the volume of the oxygen gas, as you can see here. As the oxygen gas is at 2.5 and the hydrogen gas is at 5. So what you see here is that hydrogen is a super flammable material. It burns easily as it's well chemically active. But then oxygen, it burns. It helps in burning. It's not flammable, but it helps when something is already burned. So this is what all we're gonna do in this experiment. So let's read the conclusion of this experiment. So when the voltmeter terminals are connected to the battery electrodes, we observe the generation of gas at both ends of the voltmeter. We also notice that the gas above the negative cathode is larger than the volume of oxygen gas, which is formed at the positive anode. So this is the student Moaaz Mohammed, and this is the Hoffman's voltmeter experiment on the VLIB website, and I'm going to see you next time.